I'm going to call upon Mr. Errol Smart, the CEO of Orion Minerals, to take us through his presentation and leave us more informed on beneficiation projects for the minerals we have in our country. Can we please give him a warm welcome on the stage?
Okay, so they're running out of mics, so I'm going to try and make this mic stand work for me so that I can talk to the audience. Okay, guys, this was thrown together with very short notice at 4 a.m. this morning, so I apologize now for anything that's untoward in there, photos of my kids or something in the background. So Orion is an ASX and JSE listed company. We came into South Africa in 2016 because we identified this amazing opportunity in the Northern Cape, where there's an absolute huge endowment of what has now become known as the critical minerals. But when we took the decision, when we started looking in 2016, that wasn't even a term that was in general use. We knew that we wanted copper, we wanted nickel, we liked zinc. But in the Northern Cape, we found an opportunity where on the same ground where we had copper and zinc, or where we had nickel, copper, cobalt, we also had rare earths. We had lithium, we had uranium, we've got graphite, we've got all of the minerals that have been spoken about today in the Northern Cape. But I'm quite interested that we've been talking about geology, and I'm a geologist, that's where my passion is. But I do know that many geologists don't even know where to find the minerals, because we're looking at the byproduct minerals. When you're dealing with these mineralized systems, you've got to look at the byproducts. That's where the opportunity lies. So although the Prisca mine that we're going to be developing first is a copper mine, 40% of the revenue will be from zinc. 3% of the revenue would have been from gold and silver. We did a streaming finance deal, an innovative financing deal, that we will recover the gold and silver and deliver it, and we got $80 million for it. The geologists need to understand the byproduct credits. And as a result of that, we started looking at the deposits that are well known. They were discovered in the 70s and 80s by the big mining houses and have been neglected because people didn't look at the bigger picture, at the whole picture. So even though I'm a geologist, I had to get involved in the upstream value or the downstream opportunity. I don't know which way you want to look at it. Just as a matter of interest, in the room, have we got the DTI today? So we're here to speak about critical metals. We're about to speak about the future of the country's mineral resources. And the DTI are not in the room. It's very sad because we're talking to ourselves. Everybody here in the room knows it. We've got to be speaking about an integrated industry if we're going to make this thing work. And we've got to be speaking to the scientists. I know Mintech are probably somewhere in the room, but Mintech, the DTI, the industry have to be speaking to each other. My little friend Musa Mabuza needs to be teaching the geologists where to find these minerals. Not about the sites, it's about the integrated mineral opportunity. And in the Northern Cape, we have those opportunities. All right. There we go. So this is Mercedes-Benz's critical minerals report. We've been speaking about countries speaking about strategic minerals, but companies, and this is the way that these critical metals work, is you're not going to mine something and deliver it to a big smelter or refinery. You're going to deliver it to end users. So the Toyotas, the BMWs, the Mercedeses, the Hyundais, the Teslas, the Nokias, they are looking for these minerals because they want to have certainty in their supply chain. They want to have the certainty from exploration right to the end product. To do that, you've got to, from the point that you're exploring for it, to the point that you produce it as an end product. And an end product isn't a big lump of dirty metal. The end product is actually a manufactured product that gets used in the electronics industry. It's a high value product. And I'll demonstrate some of it. But just in the Northern Cape, on our existing mining rights, if we could just get the DMRE to handle all of our Section 102s and all of our prospecting rights that have been outstanding for years, we will have all of these minerals available in a coherent form that we could be mining. And that's where the value chain comes. Because some of these minerals have been sterilized because of slow regulatory movement. Now, I know there's a lot of effort at the moment to get that caught up, and we're hugely thankful for that, but it needs to speed up. It needs to speed up because the industry, the world is moving on, and we are going to be left behind in South Africa. So this is just Orion's mantra, is everything from exploration to the final product, we would like to be able to track that value chain. Because the Mercedes and the Nokias, that's what they want. They want to know that the product that they're using in your cell phone is responsibly sourced and responsibly mined and manufactured. So just the history, people think about refining as big smelters. The refining world, when we started investigating it, we realized that it's a very opaque world. You don't actually know what happens behind the gates in the refinery world. But the high-end value products, that's where the money is made in the refining world. But they are price determiners. They tell the miners what they're going to pay. And the miners right at the bottom are the price takers. And lo and behold, the poor explorers, one step beyond that, they're the guys that really struggle. So unless you get into a situation where you can control your whole value chain, you're not going to unlock the value. Now, we all know the picture, the archetypal picture of what refining is. And we know that refineries are sort of expected to be big, dirty, belchy, energy inefficient, wasteful things. We produce metal concentrates, we produce sulfide concentrates, and we ship them around the world, and 70% of what we ship gets turned into a waste product and gets ditched on a site somewhere. And at best, maybe 30%. In the zinc world, maybe 50% gets turned into something valuable. The rest of it is a waste product. South Africa's got a problem. The region's got a problem, people. Don't expect to be building smelters. It's not going to happen. It's not going to happen in this decade, and the boom is on us now. We've got to find a different way to do this. We've got to get away from the energy-intensive, wasteful, polluting refinery technologies. So we've got to get away from the smelting. We've got to break this chain. And we went looking for one, and there's a number of opportunities where this is happening. People are looking at biological leaching and acid leaching. There's all sorts of solvent extractions going for the metals at the moment. Those technologies are rapidly developing, and because my passion is with the junior miners, what I really like is what's developing is the old smelting technology needed big, massive capital, massive infrastructure, long lead times, big mines with 30 years of life ahead of them to get something built. The modern technologies that are becoming available, the acid leaching, the solvent leaching, the biological leaching, the solvent extraction, electro-winning things, that is something that the juniors need because it becomes applicable at the project site. And that's when you get the value being developed at the project site. So I don't want to compete with Anglo-American and Kumba. We're not bulk players. I'm not going to compete with Pushpenda and a fantastic zinc refinery that the region definitely needs. What I want to compete is I want to build little pocket rockets that make a lot of money in a short period of time. And that's what's going to really simulate the junior mining. So I'm just going to run through it. We chose one technology. So we looked at 10 different suites of technology. And what we got exposed to is metal vapor leaching. It's something that's kept very secretive. But Vale do the carbonyl leaching on big scale, in very nice, clean, clinical laboratory scale. They produce these fancy products that go into 3D printing of metals, that go into the electronics industry. Tronox build these massive chloro vapor plants around the world. So the technology is well known. It was developed in 1902 for the first time. It's been operating for more than 120 years. The materials are known, the science is known. What hasn't been known is how do you downscale it? How do you get it to a manageable scale and not building one of those big complexes that would take you 10 years and would cost you billions of dollars? Well, there is a way to do it, and we're busy working on that, and by the end of the year, we expect to put something in the public domain that will show how you can do it on a pocket rocket scale. And that's what really gets me excited. And what really drew us to this is when these scientists, and I've got these absolute rocket scientists busy working on this, and when they came to me and they said, Errol, do you understand the value addition by doing this kind of refinery? I said, oh guys, how much can it be? You know, so you're going to make LME plus 20%. They said, no. You're going to make LME times 10, times 100, times 1,000. This is on the internet. When I presented this to my board a year ago, this was a year ago now. This is an iron powder, a carbonyl iron powder. Look at what it's trading at. $105 for 1 kilogram. You know, Kumba, you'd love to sell your ore at $105 a kilogram. We're speaking about $100,000 a ton for iron. For iron. And that's where the opportunity lies in beneficiation. And if we get this beneficiation right, and if the DTI was in this room supporting the industry that has to do the critical minerals, we'll get a lot further down the line, a lot quicker. So, Musa, doing a great job on the geology. Industry is willing and able and wanting to go. What we've got to do is bring the beneficiation side to the table now to actually close the circle and make it work. So just very quickly, I'll show you some other examples. This is a different kind of iron powder available on the internet, $43,000 a ton. Copper, you know, geez, I've just done a bankable feasibility study for copper. You're running at $3.80 a pound. This is powder, high purity copper powder. It's trading at $25 a pound, 10 times the value that we're busy planning our mine on. And this is achievable, it's within reach with known, proven technology. Zinc. You know, this is done. It's done by the zinc refineries around the world. It's done behind closed doors because this is where the value lies. You know, what do you pay for the zinc that you drink every morning in your mineral supplement? But we're getting paid $1.80 a pound. Look at the value that can be created. And this can be done on small scale. So we've chosen a technology that's specifically dry, no water. It is self-generating in power. So you've got to get a power into it to get it started, and then it actually generates power because it's an exothermic process. It's a sealed system. Nothing leaves. No vapor, no gas, no liquid leaves unless it's a high-value product that is sold to somebody. And the dry solid is an absolutely high-quality glazing. This can be done, and it can be done in South Africa. And there's other ways of doing this that aren't necessarily this environmentally friendly, but this is the future of unlocking the value chain of critical minerals in South Africa, and particularly for the junior miners, because it brings it in our reach. All this talk of the lithium. You know, lithium, people have figured out how to leach it. And that's why the juniors are climbing in on it. And that's why it can be done in Namibia and it can be done in Zimbabwe, and they don't have to ship it all to China to get it done. That's where our opportunity is, people. So I'll leave it at that.